I think everyone has heard about Spot, the robot that is there in the angle. I think yes, everyone noticed it. But I'm not sure all of you knows what is done for. And this is the question that we tried to solve with Tom, and that is, okay, it's a good toy to make features, but it's also a valuable tool to perform other kind of stuff that are also security related. And this is our use cases. This is one of many use cases that we could say, but this one is robot-based inspection for industrial security. So using Spot to perform something that I won't anticipate and protect better our critical infrastructure. That means industrial fields, networks, or physical assets, or also safety of people. So it's a huge world. I worked for 5 years in the energy world, so it's something that has multiple limitations in terms of security, because we are not only talking about digital assets, but also about PLC, physical assets, so PLC, actuators, and so on. So if we go one slide ahead, even here there is the dream team, of course. It's bigger because the robot is bigger and it's heavy, so it requires many people to be taken. I want to thank a lot to Ghelen, that is our Brussels Liquid Studio lead that came here from Brussels just to take the robot here. So thank you very much. So let's go one slide ahead. One high-level interaction about robot interaction that is not security related. So what these robots are made for? Are made for collaboration, they are made for automation, and for security. So they can do something that I could do by my own, but in an autonomous way, and in areas where I could not be able to behave or to work, because they're dangerous, because they are too wide, and so on. Or I'm not 24 hour and I cannot work 24 hour a day for 7 days a week. So if we go on a slide, the robots are evolving. Some of these you already know because they are in your house. There are, for example, they share your space, like the Roomba. I read an article that was really interesting, in my opinion, that people are starting giving names to the Roomba because they feel sick about them. They clean better the house before they clean because they feel guilty, like my mother when people come at home. So it's a thing, and we are familiar with them. There is another one, the interface sharing, that basically they are able to act in the same way as we do. They can open doors, for example. Not this one because we didn't take the arm, but they basically can work where we work, they can use what we use. And on the other hand, they knows and understand our language. We also have a use case that we don't show today, but for which we could instruct also the robot by voice, using LLM. So integrating it, and they will understand, because technology will mix digital goes to physical and interact in a way that is natural to me, like prompting, like generative AI, like robot interaction. If we go one slide, so even here, I would like to leave space for the interesting part, that is the robot, so it's not me. But there are a lot of interesting applications for this kind of assets. From the boring stuff, things that I don't want to do at all, like making coffee, for example, or cleaning house, I think, for me, to automated operations, logistics, industrial logistics, moving packages, deconnect a bomb, or looking for people yeah, the fuse, thank you very much. Now it's better in English, you can interact more. And there are many hours of application. One of these, of course, is cybersecurity. This is my specialization, my area of expertise. If we go on, so even here, we have a lot of the different assets. I won't go in details, but we have, for example, robots that are able only to move for logistics, so they move on floor, on flat floors. There are the drones that can go by air. There is robot services that do a specific task and come back. So like Emilio Meglio, so if you recall the robot, but basically a robot in the restaurant that take the order and come back. Automated arms, for example, a robot with legs, and this is maybe a specialization of a certain one of these because they are able to go on difficult fields that are not flat at all. And then robots on wheel. So you can expect this. I won't go in details on any one of this, but one concept I think is interesting. We and everyone started reasoning in terms of robot fleets. So connected robots that interact each other and perform maybe the same tasks, and I can choose the right robot to perform a specific tasks depending on the task itself. So if I need to inspect a wide area, it could have sense to use the robot by floor, but I can also use the drone to go by air, and I can integrate the same information in an aggregated panel for my security operations center to work in an integrated way. So this is a thing in industrial, they use it. Even if you buy on Amazon, they're using this robot and they're working in this logic. So even in this case, it's not far from your place, from your home, and from what we will see way more in the future. If we go in another slide, just one word on what is industrial security. Maybe you're not familiar with it, and I think it's important to set the boundary for this. We talk about critical infrastructure when we say everything that provide the critical services, energy, transportation, water supply, exactly. On top of this, all these systems are regulated by industrial control systems. These systems have specific tasks to control these devices. They monitor the temperature of the nuclear central, or they perform they understand how to rotate a specific tool and set to ventilate an area, and so on. On top of this, there is industrial Internet of Things, all the assets that are network connected with one each other that have specific role in an industrial pipeline. So GPS, drones, robots, and so on. On top of this, there is Internet of Things. Everything is connected. Domotics, Google Home, or Alexa, or whatever you have in mind and you have at home, smart vehicles, and so on. Yes, exactly. Why security? Even in this case, I think you're not very familiar. Let me see how much time I have, but I promise I'm finished. Security, industrial security is a thing. Stuxnet was the first one. I think it's really interesting. It's something that we face every day in our life, in our professional life. So we started in 2010, but this is the first documented attack. We don't know if there were many others in the past. I will go in details 1 second for this, but the important information I want to give you is that these malware are evolving. They are moving, for example, to first attack only industrial field, then moving to corporate field, moving to Active Directory, like Shamoon, for example, going to do denial of service, so disconnect completely the erogation of energy, for example. All these attacks are real and have been done over the years. We are talking also about malwares that attack the safety of users. So that is another important part of the industrial security. So malware are evolving, are extending, are integrating field and corporate environment to go end-to-end from the endpoint, from the workstation where you work to the field environment. Stuxnet, if you go one slide ahead, is very interesting in my opinion, because it's something, when you think about malware, you also need to think that field environment, especially the oldest one, are air-gapped. They are not usually connected on internet. Things are changing right now because the business requires to be more and more connected to gather data and address the investments, but it's not the point. But basically, Stuxnet, what it does, it infects the systems through USB. Why USB? Because if a system is air-gapped, I cannot go on the internet. So the only thing I can do is put an USB on the floor and make it used by the user. The user will use the USB. The malware will spread in the similar way as we showed before, or laterally. it will use the CVEs in the 0 days to attack other assets. And this is interesting because this malware went to slow down the centrifuges. I don't know if it's the right word, centrifuge, sorry, I don't know if it's the right word, just a little bit to make them break. And this slow down the development of industrial nuclear energy in Iran by many years. So it's simple attack, but the impact is devastating. If we go one slide, I think I can leave you the stage. I will stay quiet to show you a real application of the Spot robot. Okay. Tom, if you want to speak, use the microphone. Okay. Ooh.
Thank you. So let me put the robot first. Can you plug in the USB, please? The HDMI. So I'm putting the robot here in front because you want to take pictures and you were waiting for it. So now you can take your pictures. Let me ask you a question. Anybody has an idea why this is only possible now? When I was young, I was watching the Jetsons. They were already looking at those type of things. So why is this only possible now? Anybody has an idea? Sorry? Yes, indeed. Yeah, there is something which is called exponential technology. And it's a law invented by Moore in '65, if I'm not mistaken. And he actually said every technology is reducing every 2 years and the price is halving. Yeah? So it's exponential. Meaning that batteries, meaning that storage, meaning that computing power is reducing. You might remember those robots with those cables hanging around everywhere. There is no cable here. What you hear is a high performing computer that is keeping the balance of the robot constantly. That's what you're hearing. It's not falling over, yes? Sorry? No, we're not allowing other people to do that because some people, they push a little bit too hard. But anyway, so that's the reason why this is possible. And it's even becoming better because Boston Dynamics, before yesterday, launched their new Atlas robots. I invite you to check it out on the internet, yes? So, thank you very much. So what you see here is what I see on the device, yes? And what you also see, it's cutting the motors. So we're going to try to go back. Okay, so this is what I see on the tablet here. This is the manual operations. So I can have moving forward. I need to put it to walk first. Forward, backward. And I see some reactions here. If I do this, yeah, some people bounce back, other people, wow, this is freaky. Yeah? There is no middle in between. It's something like new cars came in the road. People had to get used to it. Yes. So anyway, so what you can do as well is have it moving sidewise like this, and the other way around. Yeah? And then you can let it turn as well, so it has different axes. Yeah? Now, what is really cool in this is I'm operating it now, but I actually do not need to operate it. So we set out a track here in the afternoon, and I'm going to ask Pellegrino to move a little bit, because you're in front of our... So what you see here is a fiducial, like they call it in English, a QR code to make it simple. Yeah? And this is representing whatever. And you can make it actually a fire extinguisher, people, a red ball, a light bulb, whatever. It's trained with a lot of AI models, so it can recognize a lot of things. Why do we use a QR code here? Because when we prepare, we do not know how the room looks like, we do not know how the light is, and those are things, so it's easier for the robot to detect. Yes. What I'm going to do now is I'm going to put it to auto walk. Yeah? People that do not like independent devices should leave the room now. Okay. So I'm going to play it back, and you can see there are a lot of things here. It's a test Rome, by the way, the second one. It's not testosterone. But anyway, so Rome breakout, that's a session that we prepared. So now I'm going to let it run. And what I'm saying, I want to loop it. So it's actually going to continuously loop every 5 seconds in this case. 5 seconds. And now what it does, when I click the play now button, it's uploading the data to the robot. wireless. Yes. So what is happening now? The robot is a hotspot now. So I'm just connected via Wi-Fi to the robot. The robot can also be connected via 5G. I'll get back to that in a minute. But also you can connect it to another Wi-Fi connection as well. Yeah? The robot is not exact at the same position and it was when we recorded the track beforehand. So it needs to initialize. Okay, so now it's running independently. And what you see is, first of all, you should see it moving here. I don't know why it's not moving, but anyway. So you should see it moving on the black, is it moving? It's sitting down, okay. So it lost the connection. So the reason why it's losing the connection is because there's too many Wi-Fi connections here. So here you see what the robot is seeing as well, yeah? And is it sitting down again, the robot? No? Okay. So you see the environment, you see the line that it's following, and also what you can see here, or you should be able to see here, is a top-down view. Yeah? So here you see the AI that's built into the robot. So it's a view from the top. Yeah? I'll click on the play button again. Yeah? So here you see the red lines are everything that the robot sees and it cannot walk into. Yeah? It cannot step over it. You see it's a full 360 view. The robot has 6 cameras in the front and 4 cameras at each side, 2 cameras in the back, and a camera at the bottom. Yeah? Just to make sure that he can monitor the environment. Yeah? We can also show a map view, but it's not going to be very sexy in this case, so this is the map view. Yeah? What you also see is, I put it to wide follow the track, so it will actually avoid all the tracks. Now it's turning off because the track has been done, so I'll reload it, restart the mission. It will actually start looking for a track if there are obstacles around it. Huh? Can I get the box, please, in the back? It's against the wall. Huh? So if I would make an obstacle, it will actually detect the obstacle, and it will notice that it can step over the obstacle. So it would automatically move away over the obstacle. If there's an obstacle in between that it cannot move around, what it will do is it will find another path. And another path can be a very new path. For example, if the table wouldn't be there and there would be an obstacle there, the robot will come back here and move that way and find a way that way. So it's fully transparent, and those are things that you actually cannot change. Yeah? So all of those things are built in. Now, what is really interesting, and when it becomes really interesting, is this is of course very visual. Yeah? But what we can do is we can program the robot fully using Python as well, or C++. Yeah? So one of the things that we did is, because for security and safety, we made a solution where the robot is programmed by an engineer. He knows what are the waypoints that they need to do in a factory. The robot walks those waypoints, but he's activated by a security officer. So a person that is sitting somewhere around the world at a desk, he goes to an AWS webpage, and he just clicks a button, do inspection. The robot will be launched in the factory. It will walk around, take pictures everywhere. He will stitch the pictures together in 360 view. Yeah? And then upload them to AWS again. Yeah? So this is the Spot robot. One of the questions we often get is, yes, but is this really being used? Huh? It is being used at multiple companies already. AB InBev, the beer, biggest beer brewer in the world, I'm saying very proudly as a Belgian, is actually using those in their factories for checking and for security reasons. We built a use case for one of our clients where the robot is constantly walking an industrial floor, checking whether people are wearing safety gear. If they do not wear safety gear, a picture is taken and it's sent to a central repository. Another example is there are solutions that you can build on top of it, and it's a high definition camera. It records specific environments, and it senses the vibrations caused by sound or by air escaping that you do not hear or see by the naked eye. And when you do that, the robot will actually indicate in colors where the leaks are. Yeah? So those are real use cases that we developed. Maybe let's open up for questions. What questions do you have?
Why Wi-Fi?
It's the only thing that's built in. Yeah, and if I want to use 5G, for example, I need to build something on top of it. So we have, which is even bigger. Sorry? You can extend it, and I didn't brought it because, just to give you an idea, to get a robot here, it took us about 3,000 euros just in transport. Yeah? So because it's the batteries are very heavy and they're very high voltage, so that's the reason why. Yeah? The battery lasts for 2 hours, and it charges in about an hour and a half.